Hello, my name is Mr. Asprey and this is Edexcel IGCSE. This is number 20, this is Indices. This is my second series of doing all exam questions, and you can find all of the questions on my Google Drive. Now 20, Indices, is a big topic. So many different types of questions they can ask. So let's get into it. And just a quick reminder as well, if you want more guidance, then do watch my video where I go through all the topics in detail with examples. So this is just exam questions. But what we do know is that when we multiply two terms that have the same base, in this case a, then we just add the two powers to get a to the 11. And the other rule is if we were to divide two terms with the same base, in this case a, we would get a to the m minus n. We would subtract the powers. So in this case it would be e to the 6. Okay, so in this one we are multiplying 3's, so we add the two powers. 4 plus 5 is 9, so m is 9. Now the other rule is that if you have a to the power m, and then that's bracketed and then raised to the power n, then we multiply those two powers. So in this case, 3 times 7 is 21, so n is 21. And here we have p, okay, a little bit trickier, but we have 8 plus 2 minus p will equal 6. Now, because the two on top are times, so we add them, and then there's a divide here, so we subtract that power, which is p, and that equals the overall power. So 10 minus p equals 6, so therefore p is equal to 4. Bosh. Okay, next one, we have 5 plus n on top, we add the powers, and then we subtract 3, because when we divide we subtract the powers, and that equals 10. 5 minus 3 is 2, so that's 2 plus n equals 10, so n is equal to 8. Bosh. Okay, next page. We have, again, very similar, 5 plus n minus 6 equals 13, because we add the powers when we times, we subtract the powers when we divide. 5 minus 6 is minus 1, so that's n minus 1 equals 13, so n equals 14. Anything to the power 0 is 1. Here we're adding the powers, so we're going to have minus 3 plus 9 is equal to n. Minus 3 plus 9 is just 6, so n is 6. Once again, we can form an equation here because we're going to add the powers on the top line, and then we're subtracting the one on the bottom there. And that is going to give me minus 3. 206 minus 214 is minus 8. So m minus 8 equals minus 3. So add the 8 to both sides. That will give us 5. Job done. Okay, page 3, multiplying, which means we add the powers. Right here, we're going to have to cube each part. So we cube the numerical part, which gives me 64, and then we cube the y squared, which gives me y to the 6. So my final answer is 64 y to the 6. Okay, here we do the same thing. We raise 3, the numerical part, to the power 4, which gives me 81. And then we do k squared to the power 4 as well, which gives me k to the 8. So we multiply powers when we get that bracket situation. And that's 81k to the 8. Okay, in this instance, I think the best thing to do would be to write it as a fraction. I find it easier when it's written like a fraction. I can see where it cancels a bit easier. Okay, good. So let's do the numerical part first. 21 divided by 3 is 7. m's, well, there is just m to the 4 on top, so that stays where it is. There's no m's, sorry, to cancel. And then we have n to the 1 divided by n to the minus 5, which means we need to do 1 minus minus 5 in terms of powers, which gives me 6. So that's n to the 6. Okay, same thing. We look at the numerical part first, raise that to the power 4. That gives me 16. Then let's look at the x cubes. We need to raise that to the power 4. That gives me x to the 12. And then let's look at the y's. That's y to the 5. Raise that to the power 4. That gives me y to the 20. So it's 16, x to the 12, y to the 20. Okay, same thing again. 8 needs to be squared, which is equal to 64. X to the 5 needs to be squared, which is equal to x to the 10. And x cubed needs to be squared, which is equal to x to the 6. So we get 64, x to the 10, y to the 6. Okay, same again. 16 needs to be raised to the power of a half. Now here's a new rule which we haven't learned yet, and that is that a to the power of a half is equal to the square root of a, which means I need to square root 16, which gives me 4. E to the 10 needs to be raised to the power of a half, and we just multiply the powers in this instance, so we get e to the 5. And f to the 6 needs to be raised to the power of a half. Again, we multiply the powers, we get f cubed. So that is 4 e to the 5 f cubed. Okay, right, again, a new rule. If we have a to the power of m over n as a fraction like that, then that means that we can do the nth root of a and then raise that to the power of m. So in this case, we've got 64 needs to be raised to the 2 over 3. Of course, you could just use your calculator to do that because it's numerical. But anyway, this would be the cubed root of 64 and then squared. Cube root of 64 is 4, and then 4 squared is 16. Okay, now with the algebraic terms, we just need to multiply the powers again. So 2/3 times 9 is 6. And for q, we're going to have to the power 12. That needs to be raised to 2/3. And 2/3 is of 12 is 8. So we get 16 p to the 6 q to the 8. Perfect. Okay, final part of this page. We've got a negative power here, which again is a new rule. And a to the minus 1 is 1 over a. It's the reciprocal. Or a to the minus 2 would be 1 over a squared. Or if we had a fraction, like for example, I don't know, like a over b, and if that was raised to the minus 1, then that would be b over a. It would be flipped over, the reciprocal. First thing I could do before looking at the powers is simplify. I've got 9 over 18, which is the same as 1 over 2, dividing both top and bottom by 9. And here I have t to the 4 and t to the 6. So I could divide through by t to the 4, and that will leave me with t to the 2 on the bottom. And here, again, dividing through by w to the 9 would leave me just 1w on the bottom like that. Okay, now let's deal with the negative next. The fact that it's a negative power means it's the reciprocal. So that means I can flip over the fraction, and that is what the negative power does. It flips over the fraction like that. Okay, now because that's all divided by 1, that's the same as it just being what it is. Dividing by 1 doesn't change the expression at all. Squaring, I get 2 squared, which is 4. T squared is t to the 4, and w squared is just w squared. Okay, next one. I'm going to use the negative power first to flip the fraction over, take the reciprocal. Okay, and we know that taking the power of a half means I need to square root. So I will need to do 16 to the half, which is 4. So that goes on top. y to the 10 to the half is y to the 5. And on the bottom, 9 to the power of a half is 3, it's the square root. And x to the 4 to the half is x squared. Perfect, so that's that done. Next one, slightly trickier. The first thing I'll do again is just flip it over because it's a negative power, so we just take the reciprocal, which flips it over like that. Okay, and then the algebraic ones, we will just times the powers. So that's y to the 15. 16 needs a bit of care though. 16 to the power of 3 over 4. Again, we could just use our calculator to do this, but just so I can show you exactly what's going on, that's the fourth root of 16 and then raised to the power of 3. And the fourth root of 16 is 2, because 2 times 2 times 2 times 2 is 16. And then cube that gives me 8. So it's 8w, and I've got to times the w 8 by 3 over 4, don't forget that, and that gives me 6. And that is my final answer. Okay, this is a little tricky little one marker. The cube root means that my power, so x, I'm trying to find out what the power is. The fact that it's a cube root means that it's going to be 3 on the bottom. The fact that it's to the power of 4 outside means the 4 is going to go on top. And then what would that do? Well, that would leave me with 1 over x to the power of 4 over 3, which is not exactly what we want. We just want the x to be x, not 1 over x. So that is the reciprocal, so we need to flip it over, and to flip it over, we change the sign to a negative. So this gives me x to the minus 4 over 3. And that's exactly what m is. It's minus 4 over 3. Okay, this one is all about powers. So I can see these are all powers of 2. So I'm going to change 4 to 2 squared. And I'm going to change 16 to 2 to the power of 4. And 2 to the k can stay as it is. Okay, bracket rule means we multiply the powers. So I'm going to get 2k plus 6. Times rule means we add the powers. So I'm going to get 4 plus k. We've got a situation here where we have two bases, both 2. They're equal, so that means that their powers must be equal. So I can say that 2 to the k plus 6 must equal 4 plus k. I can subtract k from both sides. I can subtract 6 from both sides. So I get minus 2. 4 marks! Lovely. Don't mind if I do. Okay, right, something similar. Here I've got 2 to the half because the square root is to the power of a half. 16 is 2 to the power of 4. When we times terms which have bases the same, we add the powers. So I get 4.5, so, or 4.5. Whoops, I don't know why I wrote that as a 4, that should be a 2. So anyway, that means that x is 4.5. Okay, we can set up a formula here. So we've got minus 6 and 5, and there's the bracket rule, which means we times the powers, over 4 dividing, which means we subtract the powers, and that's equal to n. Okay, so that's it really. So whoops, apologies, that should have been a 5. So minus 30 minus 4 equals just minus 34. So n is minus 34. Okay, tricky question here, but I can see that all the bases are powers of 2. So I can change 8 into 2 cubed. And I can change 4 into 2 squared. Which is then raised to the power of 6, which is then cube rooted. And that's a new one. Well, the cube root is the same as raising it to the power of a third. So instead of cube rooting, I could raise that to the power of a third, like so. Okay, right, so let's do each term separately. So bracket rule here means we times the powers to make 6, so that's 2 to the 6. bracket rule here, I don't want to make a mistake here, so is 2 times 6 times 1/3. And that's 4. Lovely. Okay, and now we've just got multiplication rule, which means we add the powers, so it's 10. So A must be 10. Lovely. Okay, and this one, okay, this one's a bit tricky. Right, there's a negative power here, and negative powers means we take the reciprocal. So rather than that being n, I can write that as 1 over n. I hope that's going to help. And that's 4 to the power 5 now. Is equal to 1 over 2 to the power 4. Okay, now what we can do is this over 5 means the 5th root. So I can write this now as the 5th root of 1 over n to the power 4 is equal to 1/2 to the power 4. Okay, so now we've got it in a situation where the powers are the same and there's an equal sign, which means that the bases must be the same. Which means that the 5th root of 1 over n is equal to 1 over 2. Okay, and now what we can do is we can raise each side to the power 5, which will then cancel the 5th root, and 1/2 to the power 5 is 1 over 32, I believe. Let's have a look. Perfect. Great, so flip both sides over, n is equal to 32. As I was doing that question, I realised there was a more efficient way of doing it, which is probably what I would do to teach an A-level class. And that is that in order to move a power over to the other side, what you could do is you can take the reciprocal of the other side's power. So what I could do is I could do this. We know this is true, like so. And what I could do is I could go to the minus 5 over 4. So the reciprocal of minus 4 over 5 is minus 5 over 4. So if I just do that to both sides, then that is going to cancel out. Because when I times the powers here, that's just going to give me 1. So that's just going to give me n to the 1. And let's see now if I do on my calculator that calculation, hopefully we should get the same answer. So that's to the power 4, which is then raised to the power of minus 5 over 4. Voila! Fantastic. Okay, welcome to the final boss question. Looks like an absolute beast. First thing we can do is, because the top is times through by 18 and the bottom is times through by 6, we can divide through by 6, which gives me that as a 3, and that will be a 1, which times by 1 doesn't do anything, so let's just leave it alone. Okay, next, the root of 27. Well, we know roots are to the power of half. And we also know that 27 is 3 cubed. And we also know that when you have a bracket situation like this, we multiply the powers. So that gives me 3 over 2, or 1.5. Okay, great. So let's rewrite this now. The top line is 3 times by 3 to the 3 over 2 is the same as root 27, as we just proved. and 4n plus 6 is the power. And that's all over 9, which I know is 3 squared, to the power of 2n plus 8. Okay, let's simplify the top line. This becomes 3, and I'm going to put the power in there as well, that might be helpful. Now I'm going to have to multiply these powers here. So 3 over 2 times 4 is 6. So that's 3 to the 6n. And 3 over 2 times 6 is 9. Okay, that's simplified. And down the bottom here we can multiply the powers to get 4n plus 16. Okay, great. So next line of working. The top line, they're multiplied, which means we can now just add the powers. So that becomes 3, 6n plus 10. So add on 1, I'm going to get plus 10 rather than plus 9. And the bottom is already sorted out. Okay, great. So now what happens when we divide, in this case 3's? We subtract the powers. So I've got to do 6n minus 4n, which gives me 2n. And I've got to do 10 minus 16, which gives me minus 6. So therefore x is equal to 2n minus 6. Bosh! I think if you want an even trickier question, try the last question of Series 1 Indices, because that one I think is even more beastly. If not, go on to the next topic. Happy revising. Bye for now.